So down here, I think people were asking about this table. Where's the second or the last page of this? Oh, here it is. Okay, so this chart and or is it out of order? It must be out of order on here. Okay, so remember when we went through this, when we're talking about a specific atom, that we have different parts of that atom. Okay, we've got the protons. They have a positive charge. We have neutrons with no charge, and we have electrons with a negative charge. Our protons are, by definition, what the atomic number is. The number of protons is what gives you the identity of that atom. If we add protons and neutrons together, that gives us our mass. Electrons, the mass of those is so small that we don't bother to calculate it into here. Now, this is the mass of an individual atom. The mass that is on the periodic table is the mass of the average based on the percentage of the different isotopes. So that's what we're getting at with this chart. Okay, we'll come back to this and talk about that in a minute. I'm just explaining to you why the mass on the periodic table for aluminum is different than the mass that's given here as 28. This, if we had 13 protons, we would take 13 away from 28, and that gives you your neutrons. Here, they gave you the mass, and they told you that it was copper. So if you look up on the periodic table, the atomic number for copper is 29. So that means that it has 29 protons. If we're dealing with an atom and not an ion, then that means that we have the same number of positive charges as we have negative charges. So whatever value is here should be equal to your electrons. That makes sense? Any questions on this chart? Anything that's on there that you don't understand where I got it from? Anybody need to talk over anything on there?
Wait, electrons, are they always going to be the same as protons?
If we're dealing with an atom, yes. Okay. Remember, we did talk about ions. We talked about a cation. And with a cation, you had more positives than you had negatives. With an anion, you had more negatives than you had positives. Oops. I screwed that up. Hold on. Hold on. Don't write that down. So you have more negative charges than you have positive charges. But these are dealing with atoms. So with atoms, these two things are going to equal each other. This is always going to equal the protons because that's the definition of it. Okay, makes sense? But this is asking you about atoms.
Is that also
Uh-huh.
Okay.
All right. So that was one of the questions that came up. One of the other questions was about this chart. So this chart is like when we did the isotope lab. Remember, you had the beads on the thing, okay? This is your mass number for each one of these. These are your abundances. They're already calculated for you. When you did the lab, you had to calculate those yourselves. To figure this number out, you take the mass times the abundance divided by 100, and you get this value. That's how you calculate this amount right here. To calculate this amount here, you add all of these things together. So add this row up. Now, on the answer key that I had last night, there was one calculation error that was right here. I don't believe that it's going to make a difference in this overall number, but this number was slightly off on the answer key. So if you just straight up copied, there was an issue with it.
So it's 90 times 51.45 divided by 100.
Yep, that should give you 46.305. Yep. And then you take 91 times 11.22 and divide that by 100. And 92 times this divided by 100. 94 times this divided by 100. 96 times this divided by 100. Yep.
On the test, are you counting sig figs for that?
No, just give me to the tens place is fine. Now I am counting sig figs on these problems. Anybody have any issues with any of this? I will be giving you all of this here. This will all be on the test for you.
You're also giving us the periodic table and the colored one. Right?
Mm-hmm.
Okay.
Yep. So tomorrow you will get a colored periodic table. So you're going to get one of these and you're going to get one of these. So I've already got the basket set up here for it, ready to go. So you get to use these. This is my version. It's been the one that I've been using up here primarily, you know, on my slideshow, so you're comfortable seeing it. That way we make sure all the numbers and everything are exactly right and everybody's good to go. All right, what about any of the mathy stuff? Any questions on that? Yes.
I have a question on the very last thing, like this one.
Oh, okay, the back page. Okay.
Review what those like numbers mean.
Okay. So this right here, this question, they want to know what element it represents. Well, remember the identity of an element comes down to the number of what? Protons. And protons have a positive charge. So I count my protons. I have 1, 2, 3 protons. I look at my periodic table and the element that has 3 protons is lithium. Then the isotope symbol here, what you have to do is you have to figure out the mass of this. We know that this is 3. We've got to figure out the mass. Mass equals what plus what? Protons plus neutrons. Okay, we've already established that these are our protons. Where are the neutrons located? Are these the neutrons or these?
The first ones.
Yep, these are your neutrons. So I'm going to count those. I've got 1, 2, 3, 4 of those. So I have 4 of these and 3 of these. So that's where that 7 comes from.
Okay. So the first number is mass, and then the bottom number is proton.
Mm-hmm.
Or atomic.
So the answer to 16 is just 7, 3, and lithium.
And this will be a multiple choice question tomorrow.
Oh, okay.
So I'll have 4 of these on there, and you've got to pick the right one.
Did you say these are going to be multiple choice? Or is
Yep.
those stuff on it? Okay.
Yep. All right, what else do you want to talk about? Anything else you want to discuss on this? Let me see. There was one other mistake. This was the other mistake that we found that I had made, and that this is an electron here. Okay, I think the answer key had something different, so make sure that you get that checked. So the atom is electrically neutral because it contains the same number of protons and electrons. So that I had messed up on, just going too fast, of course, trying to get too much done. What else do you want to talk about? Huh?
Oh, yeah.
Quantum numbers. Okay. So quantum numbers, they had asked over here, which is your second page. I've got this out of order, so I'm sorry about that. They wanted to know the quantum number for osmium. So if I go, and I'm going to pull up my, oops, yep, you're right. I'm going to pull up this periodic table to be able to talk with it. Your periodic table that you're going to have is going to be very similar to this. I think this might have a couple extra elements that are marked on it, but you'll have your other periodic table there for reference. Okay. They wanted us to figure out where osmium is on here and figure out its quantum number. Okay, so I got to find osmium. Osmium is under iron. So it's right here is osmium. Okay, so here's my osmium. I'm going to go up until I get to my first row here, and that tells me what my N value is. N says period minus 1. So for osmium, my period is 6. 6 minus 1 is 5. And then I just move down. This is a 2, a -2, and a minus. So that's the quantum number for osmium.
When number 14 it says, what is atomic mass? How do you calculate it? You just wrote the equation. So do you need to explain atomic mass or no?
Yeah, it's just the number of protons and neutrons in the nucleus. I don't know how else to explain it other than to just give you the formula.
Okay.
What does number 11 even mean? Like, what is...
Here?
Yeah.
So they're talking about the atom and the nucleus here. The nucleus is really dense. It has a large mass. So most of the mass is contained in there. And that's because it contains the protons and the neutrons. Okay. Remember, these are what have mass compared to your electrons. It's positive because you have the protons in there, and the neutrons are neutral, so they're not going to to balance that out. The electron cloud then is negatively charged because of the electrons, and the atom is neutral because you've got the same number of protons as you have electrons. The positives and negatives equal each other. Okay. Other questions? Riley. Number four. Okay. All right. So number 4, tomorrow you're going to have a much more simplistic drawing here. Okay. They are asking you if n equals 6 and that electron moves to n equals 1, what is the energy given off? Well, here, if I follow this up, this is 6. And if I find where that transitions down to 1, it's this line right here. Here is n equals 1. So the transition from here to here would give off light that has a wavelength of 94 nanometers. I am going to convert then the nanometers into meters. Now, I've already done this step for you on the test. So I've already got it into meters for you. Then you put it into this equation. This equation is listed at the top. It tells us energy equals Planck's constant times the speed of light divided by wavelength. So I write in Planck's constant, I write in the speed of light, and then I'm going to divide that by the wavelength that I calculated here. When I do it, it gives me this joules for energy. Then if I continue, now my n is 3. So I'm going to find this shell that is 3. I find the line that connects the 3 to the 1, and that's 103 nanometers. Sorry, 103 nanometers. Convert that into meters, and then I plug that into the equation, the same equation. You can see that this energy amount is greater than this energy amount. So the longer the transition between that electron goes, the more energy it's going to release. And that was number 5. What else do we want to talk about? Ready to take the test?
Right now?
Yeah.
Right now?
Yeah.
No.
Then ask me questions.
Can I open the bathroom?
God, you're such a joke.
Can I actually?
I can roll my
Can you
eyes,
explain
right?
5?
Huh?
What?
5? Like, because it uses question 4. So might as
Right.
well.
So 5, that's what I was just saying, 5. This is a much longer transition here.
Uh-huh.
That is going to give off more energy than this shorter amount. It's kind of like if you think about it, if you fell from a ladder, if you fell from the top of the ladder all the way to the ground, you gain more energy, you going down, right? More kinetic energy than if you fell from like here down. You do less damage, right? Same idea. Okay. You give off less energy if you are transitioning a shorter amount.
I have a question.
Uh-huh.
How do you figure out the valence of something?
Valence electrons.
Yeah.
Okay. Let's go back over to my periodic table here. All you have to do is count the column it's in, skipping the D block.
Oh,
So 1, 2. So anything in this column has 2 valence electrons.
okay.
I skip this 3, 4, 5, 6, 7. These would have 8 valence electrons.
So 8's the
So it's
highest you
like
can
1
have.
to 2 or
1, 2,
3 to
skip a few.
and
Yeah.
then is that the thing with like
The
dots
dots,
around the-
yep. So if we wanted to do like the electron configuration for iodine here, okay, 1, 2, skip a few, 3, 4, 5, 6, 7. So I would put 7 dots around the iodine.
It doesn't matter what what side and if it's has 2 and one has 1. Does that matter or no?
Well, you want to like split it off evenly. So like if I had oxygen, for example, oxygen has 6 valence electrons. So I always go 1, 2, 3, 4. So always spread them out and then double up. 5, and then you want to have this one over here that's 6. Or you could draw it like this. But you want those,
You want at some
opposite.
point doubled up.
yeah.
For like that.
Oh.
For 7, for the test, will we be able to use the abbreviated?
Where does this? Let me get
Because it
over to
says
here.
on
We go.
the 7
Yep.
that it's abbreviated is fine.
Yeah, I have that on the test. Yep, that's
Okay.
the same thing. Like I said, I just copied the test over. I tried to leave every instruction, everything the same. What I did change was this image is changed to a different element. And then this guy, I gave you an easier diagram here.
And then for 1, 2, and 3, will the equations still be pretty
Yep,
much the
yep.
same?
They're exactly this. They're
Just different numbers.
yeah.
So like
I
E would equal HB for number 2, and that would be the equation.
well, I might have gotten rid. I don't think I gave you as many on your test as you have here. So you can't go that this one's gonna. But they're in the same order.
Okay.
So I just might have. All right. What else do you want to talk about?
For 7.
7. Okay.
Electron configuration. That's like the one thingy, whatever. Yes. Okay. Can you also go over? I think I know how to do it, but just like go over how to do an orbital diagram.
Yeah.
Do we have to highlight the things, like how we use it on the homework, on the test, or no?
Is it school?
Highlight, okay.
So orbital diagram. Let's just do titanium. Okay. So the first thing I'm going to do is I'm going to start out writing the electron configuration. Oh, shoot. I'm sorry. Sorry. Come on.
And for electron configuration, the noble gas trap does not work. You can't use that, right?
Right.
Okay.
Okay. So let's do titanium here. I always start back here at the beginning. Shh. I always start back here at the beginning. This is my N value. My N value is my period when I'm in this block. So that's 1. This block is known as the S block. And if I'm going to titanium, I need both of these. So that's 1s2. Then I'm going to go down here because after helium comes lithium numerically. So this is my period, again, is my N value. So 2s, and I've got to have both of them. This is number 4. Number 5 comes over here to boron. My N value for boron, again, continues to be the period. But now I'm in the P block. I need all of these, which is 6. After number 10 comes 11 and 12. That's down here. Again, my period is my N number. And that is the S block. And I need both of those. This is number 12. So I come over to 13. Get 13 through 18 here. Again, period is my N number. So that's 3, P. And I need all 6. This is number 18. So I'm going to come down and grab 19 and 20 here. 4 is my N value here because it remains period. I am in the S block and I need both electrons. Now, when I come over here, my n value is no longer period. It's now period minus 1. So I'm going to take 4 minus 1 is going to give me 3. I'm in the D block, and I need 2 electrons to get to titanium. All right, so that gave me my electron configuration. Now I'm going to do my orbital diagrams. So the S block gets 1 blank. So 2, 1 blank. 2p, P block gets 1, 2, 3 blanks. It's for these 3 orbitals. This is the same orbital as this guy. They just double up. So that's where I get my 3 for 2p. Then I have a 3s, 1 blank. Again, just 1 orbital there. My 3p gets how many blanks? 3. 1, 2, 3. Then I'm going to do 4s. That gets 1 blank. And then 3d gets how many blanks? 5. And that stands for these orbitals. So if you forget how many blanks you need, all you have to do is look and see how many M numbers you have in that section. And that tells you how many blanks you need. So it's going to be 1, 2, 3, 4, 5. Now we're going to place our electrons. I'm going to place these 2 right here. These 2 I'm going to put here. These 6 I'm going to do an up, 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 and then I repeat down, down, down. These 2 are going to go here. My 3p, I'm going to do 6, 1, 2, 3, 4, 5, 6. Here is my 4s. And then finally the 3d, I need 2 electrons. They both have to go in separate orbitals. Good?
Yes. Thank you.
Yeah. What else do we want to go through?
Did we show you our review completed? You did the points, right?
Mm-hmm.
Did I show you?
I didn't know it was due. It didn't say that in the request.
It didn't.
So I had no idea that was supposed to be due.
I thought it,
I
like
thought
we
we were
purposely leave it blank so that we could. That's but I only did that with 1 slide.
All right. Does anybody have any other questions about the review? Are we done talking? You just want some study time? Okay. Let me stop this video real quick.